In last class, we discussed the position time graph, and now in today's class, we are going to discuss about velocity time graphs. Velocity time graphs, beta. So already position time graphs is completed. Now we are going to discuss about velocity time graphs. In this velocity time graph, first we will discuss about particle at rest. Particle at rest. So now particle at rest we are going to discuss. So when a particle is rest means, what do you mean by rest? Velocity is zero. Particle at rest means initial velocity is zero or final velocity is zero. We call the particle at rest. So now we are drawing the graph for velocity time. Velocity is taken on y-axis. Time is taken on x-axis. When we are plotting the graph for velocity time graph, and velocity is taken on y-axis and time is taken on x-axis. We just now we told that velocity value is zero. Particle at rest means initially this velocity is zero. Every time its velocity will be zero only. There is no change in velocity. Always the velocity is zero. So if you don't draw any graph like that, and simply if you leave like that, it indicates that is particle rest. Actually, the graph we will have to draw on positive x-axis like this. You can't observe that one. Here, okay, blue line I have drawn on the black line, something it is like that. But here, everywhere velocity is zero at any particular time. Velocity is zero. So we have taken the on y-axis, velocity, and on x-axis time we have taken, and we are not drawing anything. That is nothing but the body is said to be in the rest condition means if you don't draw anything or just leave it like that, or we can say that the graph is straight line along x-axis. We can conclude graph is straight line. Graph is straight line along x-axis. Straight line along x-axis. We can call it as the particle is said to be at rest. Particle is said to be at rest means graph we can write straight line along x-axis here. So this is the information for particle at rest condition for velocity time graph. Now let us observe another one. Second case, particle with uniform velocity. Particle with uniform velocity. So whenever we say the particle is traveling with uniform velocity means velocity is constant. I told you that if velocity is constant, then acceleration is zero. Acceleration is zero. Why? Because acceleration is rate of change of velocity. Acceleration is rate of change of velocity. So here this is y-axis, this is x-axis. On x-axis we are taking time, on x-axis we are taking time, and velocity we are taking here. If suppose the velocity value is constant, that value v is equal to, let us take that constant, velocity is constant we are telling. Let us say it as u. Let us say the velocity is u initially, that value only we are taking it as constant. At any particular time, the velocity is not changing. Already I mentioned that one. Whenever we got that information, we have to draw one line parallel to x-axis. Parallel to x-axis. Here it indicates that u value is not changing. U value, what is there at starting? Everywhere it is same. Your time is changing from one point to another point everywhere, but velocity value is not changing. Velocity value is constant for change of time. Then we call this as particle moving with uniform velocity. Particle is moving with uniform velocity. Whenever you say velocity is constant, acceleration is zero. Acceleration is zero because acceleration is rate of change of velocity. From here, what is the conclusion we got? We got straight line. We got straight line passing. This is a straight line we found. Straight line graph we got. Straight line. And it is passing. How it is passing, beta? It is like parallel to x-axis. It is parallel to x-axis. Parallel to x-axis. The straight line now we observe that is a parallel to x-axis. And what about the slope? Somebody asked me slope. Slope means now it is parallel to x-axis, means the angle between x-axis and the graph. Already it is on x-axis. What is the angle between x-axis and graph? 0. Actually slope is equal to tan theta. Here the theta value is 0. So I can write it as slope is also is equal to 0. Slope is 0. No slope here. So what is u? U is also called as y-intercept. U is called y-intercept. Y-intercept is positive. So we have taken from positive y-axis, and u is initial velocity. As velocity is constant, whatever the initial velocity is there, same velocity is continuing. So we can take that expression for the straight line parallel to x-axis means y term constant. What is y term? U. U is constant. So slope is 0. Y-intercept u. Graph is straight line parallel to x-axis. Like that, we have to write the graph for this particle with a uniform velocity condition. Particle with uniform velocity. Next, let us observe. Next step. Third one. Particle with uniform acceleration. First one we observed rest condition. Next, uniform velocity. Now particle with uniform acceleration. Uniform acceleration. So particle is moving with uniform acceleration. So now your particle is going with uniform acceleration means what we can say here. So uniform acceleration. That means A value is constant. A value is constant. A is constant. Now how to handle this situation? We have to plot the graph for velocity and time. So we know that velocity is taken on which axis? Y axis. Velocity is taken on y axis. Time is taken on which axis? X axis. Fine. We are happy in this regard. Now what they are saying is, what is the equation connecting with velocity and time is? V is equal to u plus at. Here a is constant. A is constant. For formality, I am writing like this. V is equal to at plus u. Why you change it like that, sir? Nothing better. I know that time is taken along x-axis. Velocity is taken on y-axis. So I can write y equal to mx plus c. I can compare the above equation with y equal to mx plus c. Y equal to mx plus c. Here m is called, what is m in this straight line equation? Why I have taken y equal to mx plus c means this is a straight line equation. Straight line equation. Now it's satisfied. M is nothing but slope. Slope is equal to tan theta is equal to, I can write, acceleration. The slope of velocity time graph will give us acceleration. We got that information from that one. Again, you observe what is about C. C is equal to, I can write it as y-intercept. What is C means y-intercept. The y-intercept value, what we got here is u. Y-intercept value is u. So here y-intercept is u, and here what type of graph we will get? Slope is positive or negative means m is positive. Slope is positive, and y-intercept also positive. Both are positive. Whenever you observe y-intercept positive means graph has to start from positive y-axis. Graph has to start from positive y-axis. And this line indicates y equal to mx plus c condition, straight line. Y equal to mx plus c condition is straight line condition. So from that, how to draw the graph? You observe carefully. I have to select the point on. I have to select the point on. Y positive y-intercept. Why like that, sir? Observe carefully here. C value is what? C value is U. And U is positive. U is positive. U is positive. So we have to draw the graph from a point on positive y-axis. From a point on positive y-axis. Let me draw here. And slope is positive. Slope is positive. Slope positive indicates with respect to time, velocity is increasing. So time is increasing, velocity value. That means as per x-axis increasing, y-axis value is also increasing. This is the y-axis. This is x-axis. So the value is increasing with respect to x-axis. Y value means velocity. Velocity is increasing with respect to x-axis. And this is the angle here, theta. Slope, we can say it is now positive. Slope is nothing but tan theta. That is nothing but acceleration. This is the graph for particle moving with uniform velocity. Particle moving with uniform velocity. So what I did here, particle moving with uniform velocity means here v equal to at plus u. I brought this equation from here. And a is nothing but now slope and u is nothing but y-intercept. Both are positive. As u is positive, we have to take the graph touching at positive y-axis point and you have to draw like that. And there is a positive slope. Positive slope we are drawing in this way, and this angle is theta here. So slope is nothing but tan theta equal to a. This is the information for velocity time graph. Next, let us observe. Let us observe now one special point, not fourth point. Let us observe one special point. Note here. Note. Suppose if u is equal to 0, u is equal to 0 at t equal to 0. That is simply actual formula is v is equal to u plus at. As u is equal to 0, I can write v equal to at. If I write v equal to at, v is taken on y-axis, time is taken on x-axis. From here I can draw y, I can write it as y equal to mx, y equal to mx. So there is no y-intercept, no y-intercept. C value is 0. C is nothing but y-intercept, it is 0. And we have slow, then y-intercept 0 means, remember, whenever y-intercept 0 means we have to start our graph from origin. So if you start the graph for origin, and what type of graph here? Slope is positive. M is equal to, observe carefully the M. M is equal to, slope is equal to, tan theta is equal to A. And slope is also positive. There is no negative sign in front of A. So it is a positive. So the graph now, y-intercept 0, y-intercept 0 means graph has to start from origin. So let us draw the graph from origin. Let us draw the graph from origin. In previous condition, here y-intercept is not equal to 0. Y-intercept is not equal to 0. So we have plotted the graph from positive y-axis. We started the graph from positive y-axis because y term is there, y-intercept term is there. So from here we have drawn the graph. But now if you observe, here what happened? It is y-intercept is 0. Y-intercept is 0. Then we have to start the graph from origin. We have to start the graph from origin. This is also velocity time graph and everything is same. And here I can take this as theta and slope is equal to tan theta equal to A. This information you know. This is the velocity time graph. Whenever y-intercept is 0 means we have to start the graph from origin. Next, let us see the next one. Now they are telling that the condition, fourth one is particle with uniform retardation. Particle with uniform retardation. Particle with uniform retardation. Retardation. What is retardation? Retardation is also called as deceleration. So retardation means simply we can understand it is negative acceleration, negative acceleration. So deceleration or retardation or negative acceleration we can call. Generally our equation will become what? V equal to, you will write it as u plus at is our equation of motion, but it is retardation. Retardation means we have to take the sign v equal to u minus at. V is equal to u minus at. So from here I can write v is equal to minus at plus u. V is equal to minus at plus u also I can write. Now as usual, what is a y? Y in v indicates y axis. We are drawing the graph. We are plotting the graph for taking velocity on y axis and time on x axis. So from that information, this time is taken on x axis. And now you observe carefully. We know the straight line equation as y equal to mx plus c. This is a straight line equation. What we know, straight line equation. So from the straight line equation, what is m? M is nothing but minus a. What is c? Plus u. So here clearly you can observe the points. C is equal to, what is c means y-intercept. Y-intercept, c is y-intercept and it is positive. Y-intercept is equal to u. It is a positive. But observe carefully now. M is equal to tan theta. M is equal to tan theta. So now it is what we can write here. Slope. Slope is equal to what we got here. Minus a. Minus a. Observe carefully. Slope is minus. That is, here the slope in this situation is negative slope. M value is negative. Slope is negative. Negative slope, how to draw the graph you have to observe. First of all, y-intercept positive. That means from positive y-axis. This is y-intercept positive. This is a plus c. So we have to generally, it is a, suppose it is a positive slope means will drop. Positive slope means will drop. It indicates y-axis term increases with respect to x-axis term. But here is not like that. Here it is a minus. Minus means we have to draw the graph like this. This indicates the slope is negative slope. Slope is negative slope. Here velocity is decreasing with respect to time. Time is increasing, velocity is decreasing. As time increases, velocity decreases. Time increases, velocity decreases. This is called negative slope. This is called negative slope. Negative slope means you have to draw down. This is the fourth condition what you have written today beta. About the velocity time graphs, if you observe the first one I have taken is the first one, particle at rest. If anybody want to take screenshots, you can take particle at rest. Particle at rest means initial velocity 0. So the line will be drawn parallel to x-axis. We can't observe anything here. Graph is straight line along x-axis. So here if we can observe, that is, this is a situation for rest, taking velocity on y-axis, time on x-axis, velocity time graphs. Next, second condition, what we told, particle with uniform velocity. Particle with uniform velocity means velocity is constant, acceleration value is 0. Acceleration value is 0. So velocity is constant and that value is what we have written, u. Initially v is velocity is u. This value always constant. Let us say that. So u is the initial velocity, its value is constant. That means time is changing, but velocity value not changing. So draw parallel to x-axis. That means angle here theta is equal to 0. So tan 0 is 0. The slope of the graph is 0. Slope of the graph is 0. So here what is y-intercept? This plus u is called as y-intercept. The point on y-axis is called as y-intercept. This is the particle with uniform velocity situation. Next, after that we discussed particle with uniform acceleration. Acceleration, uniform acceleration. We know equation of motion v equal to u plus at. Just shuffle the terms. We brought at this side, u that side, and we have written v equal to at plus u. Now you observe, velocity is taken on y-axis, time is taken on x-axis. We can write y equal to mx plus c. M is slope. Slope is equal to tan theta is equal to a. So c is called y-intercept. C is called y-intercept. Its value is u. And m is positive here. Observe, before a no negative sign, positive. Before u also positive sign. So we can write both are positive, positive. And a is constant here. This is the velocity taken on y-axis. Velocity taken on y-axis. Time taken on x-axis. So positive, c is positive value means you have to start from positive y-axis and you have to draw the graph in this way. Slope is positive like this. This is a positive slope. And again, here it is a positive y-intercept. Positive y-intercept, positive slope. I can write this is positive slope. Positive slope. Now, next one. After this, we took some note point here. If u is equal to 0 at t equal to 0, u equal to 0 at t equal to 0, velocity is taken on y-axis, time is taken on x-axis. u0 at t equal to 0 means you have to start the graph from origin. We have to start the graph from origin. And here a is positive, a is slope. Already we know that slope is positive. Positive slope, drop. This indicates positive slope. Positive slope. A is constant. A is constant. Here we are discussing for constant acceleration. A is constant here. A value is constant. A value is constant. Straight line indicates slope constant. So A is constant. Next page. Here what we discussed, particle with uniform retardation. Retardation means deceleration. Deceleration means negative acceleration. Negative acceleration. So minus a, generally we equal to u plus at, but here we got minus sign. Just I shuffle the terms. First I wrote minus at plus u here. So here actually we are comparing this equation with straight line equation because time is taken on x, velocity on y and x are there. We have to compare with straight line equation. C is called y-intercept. Y-intercept value is positive. Y-intercept value is positive. M is called slope. Slope is tan theta and its value is negative. Tan theta, its value is negative. So here y equal to mx plus c. Y is equal to mx plus c. M is negative and c is positive. So first observe c positive. C positive. Positive means from positive y-axis. M negative. Negative slope. Negative slope. So you have to draw that down. You have to draw down like that, not up. Here velocity value, negative slope says that velocity value decreases with increase of time. Velocity value decreases with increase of time. That is by negative slope. We can understand that information by negative slope. This is the information for velocity time graphs. Velocity time graphs. Now, let us see acceleration time graphs. Acceleration time graphs now. Acceleration time graphs. So when we observe acceleration time graphs, now we are taking only two conditions here. Only two conditions. The first one, that is particle at rest. Particle at rest. Second condition, that is a particle at rest one condition. Rest means acceleration 0. So nothing to discuss when acceleration is 0 means, okay, particle at rest is a acceleration 0. Nothing to get tensed. Let us take one is constant acceleration. Constant acceleration condition. Other one is non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration. Constant acceleration is also called as uniform acceleration and non-uniform acceleration. Only two conditions we are going to discuss here. Okay, if you want rest, that one also we can discuss. That is not issue. Here you observe these two here. So acceleration is constant means what is the graph you have to draw? So acceleration time graph. I'm taking acceleration y-axis, time is on x-axis. Suppose if A is equal to A naught, let us say this is A naught, say. So this A naught is constant, A naught is constant. So A naught is constant and it is on which axis? You have to take on y-axis because the acceleration is on y-axis. So the graph how we get for this one means we get one line parallel to x-axis. So parallel to x-axis means here theta is equal to 0, slope is equal to 0, slope is equal to 0. There is no slope here. Y means constant acceleration, constant acceleration. So in constant acceleration means we will draw one line parallel to x-axis. I think you remember when we discussed one topic here, constant velocity. So constant velocity also you observe here, constant velocity drawn one line parallel to x-axis. Constant velocity drawn one line parallel to x-axis. So velocity we told it is constant. U is the value initial. Every time its value is same. Like that similarly here constant acceleration time graph. So here also what we are doing now, acceleration A naught is constant, like that we can write. A non-uniform acceleration. Now let us observe for non-uniform acceleration. Non-uniform acceleration means we must not draw any line straight like that. If you draw in this way, zigzag like that, this is non-uniform acceleration. Everywhere acceleration is changing. So we can also say this is graph with variable slope. Graph with variable slope, So slope is changing everywhere. Slope is changing everywhere. Then we call it as non-uniform acceleration. Here we are taking the situation as A equal to 0 at T equal to 0 because we plotted the graph from origin means acceleration is 0 at T equal to 0 and every time acceleration value from 0 it is changing 1, 2, 3 like that. The acceleration value every time it is going on changing. It's not fixed value, it's changing. So we'll take it as a variable slope and we'll plot the graph in this way. So this is the graph for variable slope, that is the acceleration variable, non-uniform acceleration and constant acceleration for acceleration time graphs. I hope you understood the velocity time graphs and acceleration time graphs. In my previous class, I explained position time graphs and how to handle different types of graphs. So you please check these things. Any doubts are there? We'll discuss in our next session. Thank you everyone.